All right, good morning, Year 7s. Let's take a look at our week 4 exercises, which is exercise 4L. So this is about ratios. Let me take you back to the very first page. We have some definitions on page 258 in this area called key ideas. And key ideas usually have definitions and formulas and things along those lines. So what's a ratio? We haven't really dealt with this word a lot before. But basically a ratio is, I'll read the definition and then I'll say it in my own words. So ratios show the relationship between two or more numbers or quantities measured in the same unit. For example, Fleur wrote the ratio 16 to 8 to compare the number of hours she spends awake each day to the number of hours that she sleeps. So looking at that ratio there, this represents the hours that she spends awake, right? Each day. But then there's this other number. Let me change the color of this number. We'll go to green. This 8 here refers to the number of hours that she sleeps. Okay? All right. So wake versus sleep. And that's a ratio of 16 hours awake, 8 hours of sleep. And that's pretty much what you want anyway. You want around 8 hours of sleep when you're an adult. All right, so let's just look at the little symbols here. If I just remove this little symbol here, it's called a colon. And the way that you say it, right, well, there's a couple of different ways you can say it, but it's down here. The ratio A colon B, this is how you read it. A to B, or A is to B. So this colon, you read it as either to or is to. It's up to you. I usually just say to. Okay, so let's take a look at some questions here then. All right, the first kind of skill that we're going to practice is simplifying ratios. So 3 to 9. Let me just quickly draw that. What does 3 to 9 look like? Well, I'm going to draw my famous chocolate bar, and then I have to divide it into, like a number of parts. Well, have a think about how many parts are there in this entire ratio. We've got 3 parts and 9 parts. Just remember, these might represent, 3 parts, cordial syrup. And then obviously with the cordial syrup, you add water to make cordial. So maybe think of something like that. And the way that I'm going to represent that is with a chocolate bar. And so if you have 3 parts cordial, 9 parts water, in total you've got 9 plus 3, which is 12 parts. So I'm going to represent my chocolate bar with 12 parts. Let me use the straight edge. There we go. Oh, that's a little bit uneven. Maybe like that. Now each part has halves. That's 4 parts. And then if I divide each of those parts into 3, I'll get 12ths. So you're not expected to do this. I'm just kind of showing you what it looks like. So the cordial, let's say we're doing lime cordial. So I'll colour in 3 parts green, right? 3 parts green. 2, 3. To 9 parts water. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've just drawn a ratio, but we're asked to simplify it. So how do we simplify? It's kind of like fractions. So if I give you a fraction like 10 over 20, I can ask you to simplify that, and most of you would know how to simplify this. One strategy you could do is to halve these fractions, right, which would be 5 over 10. That's halving both of those numbers. And then dividing both sides by 5, which would be 1 over 2. It's the same thing with ratios. So can we halve these numbers? Well, No, we can't, because both 3 and 9 are odd numbers. We can't halve. Could we divide both sides by 3? Well, yeah, 3 divided by 3 will give us 1, and 9 divided by 3 will give us 3. So the answer would be 1 to 3. All right? And so what have we done here? Basically, we just simplified. So 3 to 9 really represents the same value as 1 to 3. Remember, we are just comparing the number of parts on either side. All right, so part B, 5/10. Kind of already gave you the answer there. Well, step 1, can we halve both of these numbers? Well, we can halve 10, but we can't halve 5, so we can't do that. Can we divide by 3? No. 4? No. 5? Yes. 5 divided by 5, right, will give us 1. And 10 divided by 5 will give us 2. So the answer is 1 to 2. All right, let's do something a little bit more complicated. Let's go to, part J, 36 to 15. This one here. All right, so first step, can we divide by 2, or can we halve these numbers? We can't, because 15 is negative. Sorry, odd. What about 3? We can, right? But 3 is a pretty small number. Is there another number that we can divide by that's a little bit larger? 4? No. 5? Oh, 5 goes into 15, but 5 does not go into 36. 6, and no, that's it. So the highest number that we can divide by will be 3. So here we go. 36 divided by 3, that will be 12. And 15 divided by 3, that will give us 5. So the answer will be 12 to 5. All right, stay tuned for another video, guys. Hope you enjoyed it.